Now let's take a look at set notation or set builder notation and interval notation. With set builder notation, we don't just write an inequality such as x greater than 3. It's written in a slightly different form. I would write the set of all x's such that x is greater than 3. Now, most people just like to zoom in on the x greater than 3 that they see there, but this form has its purposes. Anytime you see this opening set notation, we say the set of all. Okay, that's just how the opening bracket is pronounced. Then inside here, it's usually going to be x's, but it can be any variable you want it to be. This will be x's. That bar is pronounced such that, and then after it you have some condition. And that's why we have the set of all x's such that x is greater than 3 in this case. Now we can use set builder notation to represent the set of rational numbers in a different way. We know from what we said a little while ago that rational numbers are fractions. So I can't just use the letter x, but I'm going to say a over b in this case because that is a fraction. And I want to say the set of all numbers a over b such that a and b are integers. That pretty much creates our fraction for us. However, we also have to say b cannot equal 0. And that would be a more formal way of describing what the rational numbers are using this set builder notation. Now let's move on and talk about interval notation. And I've got 3 columns here set up, and I'd like to really make sure you understand how this interval notation works. Let's say we have the inequality x is greater than 1. On a number line, and I'm only going to draw 1 as the key number here, we would not be including the number 1, but we would be referring to all numbers that are greater than that 1, like that, and shading in the arrow at the end of the number line refers to this pattern continuing on forever to the right. Now, some people, when they draw this on a number line, use an open circle, and sometimes you will see that written with a parentheses instead, meaning do not include the 1, but include all the numbers greater than that 1. In interval notation, we say start at the number 1 and go on up to infinity. From 1 to infinity, always starting with the smaller number and going to the larger number. Now let's contrast that with x is greater than or equal to 1. On a number line, if we were to draw the picture, we would be filling in the circle at 1 and then shading all the values to the right. Sometimes instead of using a filled-in circle, we use a squared bracket instead, and that squared bracket represents that equal sign. Well, that helps lend us the notation we're going to use with interval notation, because when we include the endpoint, we use a squared bracket notation. So this would be also from 1 to infinity, but that squared bracket, by contrast, would tell you that the endpoint is included. We never put a square bracket next to the infinity because infinity is not a number, it's an idea, and you can never equal an idea. So we just use a parentheses at infinity, and that's an always statement. Now let's look at x is less than 3 and x is less than or equal to 3. On the number line, again, we would have open circles at 3, shading to the left for the less than graph, and a filled in circle at 3, shading to the left for the less than or equal to. In interval notation, both of these graphs would start at negative infinity, not negative 3, and would go up to 3. But with the first graph, we will use a parentheses, and the second graph, we will use a bracket to denote the inclusion of that right-hand endpoint. Now let's focus on a compound inequality. Let's write 1 is less than or equal to x is less than 3, including the left-hand endpoint, but not including the right-hand endpoint. On a number line, we would fill in the circle at 1 and open the circle at 3 and shade the values between those numbers. And we would pronounce this the set of all numbers between 1 and 3 inclusive of the 1. Or sometimes we say, or inclusive of the left-hand endpoint. Now, in interval notation, we will use a bracket at the 1 and a parentheses to denote that we are not including that right-hand endpoint. So you can mix and match all of these brackets and parentheses as you need to. When you have an inequality such as x is not equal to 2, that represents all values but 2. And on a number line, we would have an open circle at the 2 with all values to the left and the right shaded in. Well, when we look at this as an interval, we basically have two regions, the numbers to the left of the 2 and the numbers to the right of the 2. So we have to write that as two separate intervals. From negative infinity up to 2, which we do not include, denoted with the parentheses, united with the next set, which starts at 2 and moves on up to positive infinity. We always use the union symbol to unite two sets together. It's kind of like the plus sign, which adds numbers together. We use the union sign to join sets together. Always going from smaller to larger, just as you would look at it on this number line graph. Let's say you wanted to exclude two numbers. X is not equal to 3 or 5. On the number line, two open circles, one at 3, one at 5, and as you can see, I'm shading in 3 separate intervals, which means in interval notation, I'm going to have to write 3 separate intervals. First off, starting from negative infinity and going up to 3, which we do not include, uniting it with the middle interval, 3, 5, and then finally uniting it with the right-hand interval from 5 to infinity. Notice parentheses are used throughout because we are not including any of those endpoints, nor are we including infinity. Let's look at two more possible notations with this interval notation. The first one will be something like x is less than or equal to negative 1, or x is greater than 5. In this case, on a graph, we would be looking at a split graph again, solid dot at negative 1, shading to the left, and an open circle at 5, shading to the right. Well, this is two separate intervals, just as we had up above, and we're going to have to join them together with a union symbol. So negative infinity up through negative 1, which we include with that bracket, united with the interval from 5 to infinity. Okay, so this is interval notation, which again is a set notation of a different type. Let's say I wanted to represent all real numbers. Sometimes we write that as a capital R with 2 bars going down because we can't really boldface it very well using our pen. If we were to graph this would just basically be the entire number line, so I'm not going to bother graphing it. In interval notation, we write that as the set which goes from negative infinity to positive infinity, and that represents all real numbers.